Greetings and thank you for your interest in the next installment in my Inventor Tips and Tricks series. This one is not so much a tip and trick because it's basic standard functionality in Inventor. It's more about, you're a beginner and you know what you want to do, but you're not entirely sure how you go about doing it. And what do you want to do? Well, based on the title of the video, it's all about how to analyze interference, or clash detection as it's known as, and also collision detection. It's making objects in your assembly clash with each other, stop when they make contact with one another. For example, I've got here, it's obviously a wall-mounted LCD screen, and it's under constraint, which means the parts they can move. If I just grab them with the left mouse button and move them, they're free to move. But if I just move it around, sort of in a 360 motion, you can see the parts behave like the other parts don't exist. What you want to do is for them to stop when they kind of hit the other objects in the assembly. That behavior it's off by default in Inventor, and that's what I'm going to start with in this video, clash detection. So to get clash detection in your assembly, what you've got to do is switch it on. So you go on the ribbon bar along the top. If you select the Inspect tab, you'll see two buttons at the very start of the ribbon bar called Analyze Interference and Contact Solver. So these are the two buttons that we'll be focusing on in this video. The first one, Activate Contact Solver. It's usually on by default in most assemblies, and I've switched it off for the purposes of the video. So I'm going to switch it on. When you switch it on, what you'll notice is it makes not the slightest bit of difference, and you may have got that far and thought, well, what have I done? I don't know what I'm doing. I'm going to stop there, and that's what my video is all about. What do you do next? Well, basically, the reason why, I'm assuming the reason why it doesn't just start computing everything and clashing them together and making them hit each other is because assemblies can get to quite some size. You could have thousands of parts in this assembly, and if Inventor was to start now computing where everything would hit and touch with all the other parts in the assembly, the computing power required to do that might be a little bit overwhelming for your PC. So what you've got to do is tell Inventor what you want it to detect. What do you want it to perform the contact with? So it's pretty easy to do. You can either just select all the parts in your assembly, or you can pick the ones where you just want to analyze the interference. You want to know, say in this bundle of parts here, just window select them with the left mouse button, you want to perform the analysis on these pieces here. Once you've windowed select them, right click, and then on the right click menu select contact set. You're going to add these parts to a contact set. Now when I click that, watch the icons in the browser on the left hand side. You get this sort of little magnet type thing appear here. I have no idea what that's actually meant to represent. I guess it's maybe two parts sort of hitting each other, and this little red thing here is sort of like a vibrating boom, things have just hit each other. I'm sure it made sense to whoever designed the icon, GG to you, but I guess that's what it is. That means they're now on a contact set. So now when I grab these pieces and move them around, you can see they now stop when contact is made with other pieces. If we just look that down from the top and just zoom in a bit further, there you go, you can see they're now stopping when contact's made. To stop that from happening, you can keep these pieces on a contact set, just disable the contact solver, and then they'll just behave as they did in the first place. Put that back on, and there you go, there's your contact set. So that's how you do clash detection in Inventor. With regards to analyzing interference is something well, is it? It's sort of the same, but it is sort of different, really, to clash detection. Interference analysis is asking Inventor to detect where parts are clashing. So you might have a pipe run in your assembly, and it's going through a brick wall, or it's going through a metal plate, and you want to know, because your assembly is that big and congested, you want it to tell you where there is clashing going on in your assembly. So to do this, you select the Analyze Interference button here. Now, this is not, again, like I've said in some of the other previous videos, it's not the best designed and most intuitive aspect of Inventor. Granted, there is room for improvement, but however, it does the job. So what you do here is you define a set for Inventor to analyze the interference on. You can either pick up just two parts, put them in set 1 and set 2, or it does the exact same thing. You can just say, right, set 1 is going to be the whole lot. Just select everything or shift and click them all, and then press OK. And then wherever there's clashing, it will give you this little red, well, it just highlights wherever the clash is. It happens to be like a little wedge-shaped clash, but that's where the clashing is. If we select OK, and we just give it a little bit more clashing, there we go. It visibly is obviously clashing, but we now know what to expect. Analyze the interference, select all the pieces, shift and click, press OK. It's now giving us a big red selection where there is clashing going on. Now, it's saying a total of 6 interferences, total of 6 clashes has been detected with a total volume of blah. So that's in inches cubed. Well, yeah, if you live in the real world and you don't like working with inches, you can go to Tools at the top, go to Document Settings, go to the Units tab, and then change the length which also affects volume to something more manageable. Millimeters, you might find millimeters, you get a reading which is slightly too large, so let's just say centimeters, click OK, and let's just rerun the interference analysis. Click the top part, down to the bottom, press OK. There you go, a bit more manageable. A bit more, makes a bit more sense to us people in the real world. Select more, and down here it gives you a list, a itemized list of all the clashes that are going on within your assembly. So it's, yeah, it's not the best. You can't make this box bigger, which would be nice. It's just, you know, it's kind of an afterthought. Someone obviously put this in to take a box on their to-do list on the production team, and then it's been left there for many years without any further improvements because it kind of does the job. So part 1 is this piece here, and it's clashing with that piece there. The centroid X, Y, and Z values, it's not a volume, it's not a sizing, it's basically their position with respect to the origin center point of the assembly. It's where they are, but that will usually mean jack all to most normal people. They're not interested in that. All they're interested in is where the clash is, and I guess to some people they may be interested in the individual itemized volumes of the clashes. Is it a large clash or is it just relatively small? The most important part is where the hell is it? That's again where this sort of falls down, because it doesn't tell you what interference 4 is. Where the hell is interference 4? You've got to kind of work it out yourself. It's this piece clashing with this piece. You can't even click the part to get it to highlight it in here. You can't click this. You know, you can hear us banging away on the left mouse button. You kind of click this, you kind of click that. You're a bit goose there. You've just got to kind of click OK and then sort of click the parts to find it out for yourself. Another thing you could do, just hit this button here, which doesn't have a tooltip of any sort, but that copies this information to the clipboard. You can then go to Word. There's one I did earlier. Just delete that and paste it in, and it just pastes that information in. You can then shut this down and then refer back to this that you've pasted in. And for Autodesk's benefit, if anyone from Autodesk is reading this, just be aware that your help pages are absolute garbage in some instances. I want a bit more information about what this is saying. I want to know what the centroid X, Y, and Z values are. So I'm going to click Help. It takes me to the landing loading page of the wiki help. That's not useful to anybody in any world, in any situation. So, you know, sort it out. Anyway, that's collision and clash detection. I hope you found that useful. That's all there is to it, really. And yeah, if you did find that useful, press the like button, subscribe for more videos if you're interested, and put any comments you've got in the comments below, and I'll get back to you guys if I can, and I'll continue to make some more videos. So thank you very much, and until next time, see ya.